So this is question number 10 of homework 2 of session 3 for time and money. The problem 6-50. So this is a sort of we can also call this sort of a deferred perpetuity. So similar to an earlier question, which is a deferred annuity. But in terms of calculation, actually, the formula for the perpetuity is even simpler. So given an interest rate of 5.7% per year, what is the value at the date t equals 10 of a perpetual stream, which is here is a perpetual stream of $4,100 payments that begins at the date t equals 20. So if we draw this chart in sort of in a graph, and basically what happens is we have like 3 dates, right? This is 0 and this is t equals 10 and this is t equals 20. So going back to the setup, it says the first payment will begin at date equal t equals to 20. So we just record this. This will be 4,100. Right, that's the payment, and it will be a perpetual, which means this continues forever, the same amount. And it's asking us actually what is the present value, right? What is the value at date t equals 10 of this perpetuity? It's basically asking us what is the present value here. So we can call this PV 10. Now, we also need to realize the formula that we learned in class for the perpetuity. It actually has a similar applicability compared with the formula for the present value of an ordinary annuity, which basically is that we need to make sure the first payment will start 1 period from today. So if you apply this formula, you need to make that assumption. But obviously in this case, if we try to calculate the present value at date 10 here, the first payment need to start at 10 at t equals 11, right? But that's not the case. So what we can do is to, again, make sure we're standing here, 19. So when we are standing at 19, t equals 19, then the first payment, which is t equals 20, will start 1 year from now, 1 period from now. So then we can use that formula to figure out this present value. But again, because this is when we stand at year 19, so this need to be PV 19. But once we have the PV 19, then we just need to discount this further back to t equals to 10 to get PV10, and there are 9 periods that we need to discount back to get this PV10. So this question will also involve 2 steps. First is to calculate the PV19 using that formula, which is PMT divided by R. And second, bring this further back to t equals to 10 by discounting. Now this becomes the future value because relative to 10, this becomes the future, right? By discounting this PV19 back to t equals to 10. And we need to discount 9 periods, right? Because there are 19 minus 10, which is 9 periods between 10 and 19. So that's basically how we can solve this question. Now get to the detailed calculation. First, put everything into Excel in the right place. That T first is the R, right? 5.7%. That's the interest rate. And then the payment, right? The payment is 4,100, right? That's the payment. And then, as we said, the first step is to get that PV19, right? And then it's very easy, just use the formula for the present value of the perpetuity, which is payment divided by the interest rate. So that gives me the PV19. But don't forget, we're not done yet because we need to get the present value of at t equals 10. But again, that simply is another step to use the PV function. That's basically PV opens and the interest rate. And now there are 9 periods, right? 9 years between 10 and 9. So we just put 9 there. And payment now, because we are only dealing with one single cash flow, so this payment is 0. And finally, we added a negative sign in front of, now this PV19 becomes the future value, right? So, and then we are done. So the final part of this is simply to copy the number back and check my work. Yes, so that's done.